And students, my name is Mr. Monroe, and we're going to be looking at a variety of tools that are used to measure conditions of weather. And want to talk about who might use these tools. We refer to them as very special scientists called meteorologists. You probably have heard them talked about or mention their title as weathermen, which we see on TV, and we see weather women. Well, they use all the information that they can gather by using these tools to predict and forecast the weather. Now, there are three major components that make up our weather, and that is actually the sun, the water that we have on the surface of our planet, and in the air bubble that surrounds our planet that we call the atmosphere, and then something that's invisible all around us. We can't grab it. We don't really feel it until it's moving. So what do you think I'm talking about? We can't feel it till it's moving. The wind, students. So we're talking about sun, water, and air are the three major components that make our weather. And we have instruments that take measurement readings from each of those components. And we're going to start by talking about how the sun interacts with our planet, and it warms our planet with light and heat energy coming from it. Now, it warms up the surface of our planet, and it also warms up the air. And you heard one of the other teachers talk about uneven heating. That really causes our weather patterns. So you might say the sun is the ultimate energy for our weather. Now let's talk about an instrument that would measure how cold or hot the area is around us. Now, Ms. Ramirez did show you all a thermometer, and primarily that is an instrument that is used to measure how hot or cold the air is around us. A common thermometer that would be used would look like this. Now, I know it's kind of hard for you to see it, so I'm going to get my demonstrating thermometer out and we'll look at it. It's a little bit larger. And as you can see, there are numbers on each side of the red marker. Now, on a regular thermometer, the red would be a fluid that's inside the tube of the thermometer, and it's sensitive to changes in how hot or cold the air is. If it's air that is pretty warm and it's heating up, you will see the fluid travel up. If it's cooler air surrounding the area, you'll see the red fluid moving down, such as this. You know, on Thursday of this week, the temperature is supposed to warm up pretty good. It is predicted that the temperature will be somewhere up around 78 degrees Fahrenheit. Now, a thermometer like this and the one that I have here, the real one, it has two sets of numbers, one set on each side. The set on this side of this particular demonstrating thermometer, it represents Fahrenheit. So we're looking at 78 degrees Fahrenheit. Fahrenheit is the customary measurement. On the other side, we have Celsius, students. Now, Celsius represents the metric side. You know, at 70 degrees, that's supposed to be the recommended room temperature. Somewhere between 98.6 and 97, somewhere around there, Fahrenheit, that's body temperature. Now, if that body temperature or the room temperature drops or gets lower, we will see the red going down, the red fluid. So that's an instrument that would be used to measure how hot or how cold the air around the thermometer is. Doesn't necessarily have to look like this. Ms. Ramirez showed you one that was circular like this. So they come in different shapes, students, but they do the same thing. They will tell you how hot or cold the air around the thermometer is. Now, the other component that I want to talk about is water. We know that most of our planet surface is covered with water, oceans, that is. But we also have water in our atmosphere, and when it falls to the earth, we call it precipitation. Miss Ramirez showed you a rain gauge. It would set out in the open and it would collect precipitation falling into the cup and settling into the tube where there's a flotation device that will float as it fills, and you can measure that by seeing where the flotation device is located. Most of the time, we use inches to measure the amount of rainfall. Here I have what I call a mini weather station. It has a thermometer and it also has a rain gauge. And this particular rain gauge on one side is measured in inches. On the other side, now remember, inches would be the customary measurement. And on the other side, it's measured in centimeters, which is the metric side. So when it rains, it would fill it up and we would take a measurement. And a good thing to remember if you've got a rain gauge, like one day it rains and you take a measurement, be sure and empty it out so it'll be ready for the next measurement the next day it rains. Otherwise, your readings are not going to be very accurate. So we've taken care of the air. Now we took care of the water or the precipitation. Oh, one more thing. What about if it snows? Can we use a rain gauge for the snow? I don't think it would be very accurate unless that snow melted in a hurry. But how about just using a regular ruler and putting it down in the snow and taking a reading about how deep the snow is? That probably would give you an idea how many inches of snow had fallen. What about the wind? Now, we know that a very important measurement of wind is not only how much wind we have or how much air is around, but moving air is called wind, right? And we know that sometimes it can come from different directions. That's important. And sometimes we need to know how strong the wind is blowing. First thing I want to talk about is wind direction. You use an instrument called a wind vane. I grew up in a little bitty rural town in northwestern Oklahoma. And some of the barns around my community had this apparatus on top of the barn that had arrows pointing in different directions. And you saw an E for east, a S for south, a W for west, and an N for north on that arrow. Right in the middle, there would be a rooster. And when the wind would blow, that apparatus would turn according to however the wind was coming, whichever direction the wind was coming from, and it would tell you wind direction. Well, it would be similar to this wind vane here. This is a demonstrator. And we can see N for north, W for west, S for south, E for east. And in the middle, we've got this arrow. Well, if the wind is blowing from the south, it's going to make that arrow point this direction, okay? So that tells us the wind is actually blowing from the south. If it spun around and it started that way, that would tell us that it's blowing from the north. You would find this up high where there are no obstructions. There are other things that would tell us too, information about the wind. How about how fast it's going? Well, that instrument is called an anemometer. It spins around as the wind is blowing it. Usually they will have little cups like you see in this demonstrator. And the faster it goes, it's telling you the stronger the wind is or the faster the wind is blowing. And on Saturday of this past week, I didn't have a wind gauge or an anemometer. I just simply stepped out in the alley behind my house and I could see the trees doing their dance. And it let me know right then that the wind was blowing very strong and fast. There are other instruments that also would tell you how fast the wind is blowing and what directions it's coming from. It's called a windsock. Miss Ramirez showed you a windsock. And I really wanted to show you guys how a windsock works. So I went to the store the other day and I was going to buy one so I could set it up in here and show you guys how it worked. Well, when I went into the store and I asked for a windsock, they didn't know what I was talking about. One young man, he asked me this. He said, "Mister, is a windsock, is it a special sock that you put on your foot?" And I was thinking, no. And I had to kind of get a hold of myself. I said, no, not really. It's actually an instrument that is used by meteorologists, scientists that study weather. It tells them how strong the wind is blowing and what direction the wind is coming from, okay? So I'm gonna put this one to work that was created by a very creative teacher here at the Environmental Ed Center. She put this one, she just made it from scratch, okay? So let's see if it works. I'm gonna get my little blower and I'm gonna create a little wind and we're gonna see if this windsock works. You guys ready? Yeah, it works, and that's how they work. When they're out straight like that, that tells you that it's a strong wind. When it slows down, we see that it's not so strong, and then when the wind finally dies, it'll lay back down and go perpendicular, vertical, okay? So where would this be used? At airports, especially airports that have small airplanes landing, because the wind can really affect a small airplane when it's either taking off or landing. And they need to know how strong the wind is and what directions it's coming from, okay? Now, there are other objects or other instruments that meteorologists use. For example, they got dials that would measure how heavy the air is. That's called a barometer. And one of these days, you might learn a little bit about that, but in the upper grades. They also use weather balloons that they release into the atmosphere, the air bubble around our planet. And attached to that air balloon is electronic devices that take measurements. But they also use satellites that orbit around our planet, taking pictures of cloud formations, weather formations, and they make weather maps such as this as a big tool so they can chart what's happening with the weather. And what really helps us out, because the United States is located in the northern hemisphere, most of our weather patterns, they will come from the west out in California or Washington State, and they move to the east. So if they know that there's a weather front out here, they can just about tell you eventually that weather pattern is going to move from the west to the east. Students, hopefully I've showed you a variety of instruments that meteorologists, and we have women meteorologists and we have men meteorologists, special scientists that use those tools to predict and forecast the weather.